So I would probably start by looking at the momentum of each object before the bullet strikes the block, and then looking at the momentum of each object after the bullet strikes the block. So mass of 0.1 times velocity of 500 plus mass of 1 times a velocity of 0. So that's the momentum before the collision. This has to be equal to mass of 1 times a unknown velocity plus mass of 0.1 times a velocity of 100. Any questions there? Alrighty. 0.1 times 500 is 50. So this is 50 on this side, and this is still just V, and 0.1 times 100 is 10. So I think V for the block must be equal to 40 meters per second. Any problem with that? No, I think it'd be 40. Am I doing my arithmetic wrong? Okay. I mean, I think setting it up is everything. If you're going to execute it, make an algebra mistake, that's not a big deal. What is the impulse exerted by the bullet due to the collision with the block? We don't have anything about force, but we can calculate change in momentum. So in this question, we're asked specifically about the bullet. So if I was to look at the impulse on the bullet, I'm expecting this impulse to probably be negative. Although I haven't said it, I've kind of made the assumption that this way is positive because all the velocities I've made are positive so far. So the impulse is going to be the final momentum minus the initial momentum. And the final momentum is 0.1 times 100. And the initial momentum is 0.1 times 500. So 10 minus 50, or negative 40 kilograms meters per second. This negative sign probably meaning to the left. If instead the bullet gets stuck inside the block, what will be the velocity of the bullet block system? This is a repeat of what we've already done, but the left side of this collision question isn't any different than what we already did. So I don't have to change that. That's still 50. The right side has changed in that the bullet and block have a combined velocity that is the same for both objects. So in this case, the velocity is going to be 50 divided by 1.1. I don't know what this is.
45.5.
Okay. Block is going faster than before, but the bullet obviously much slower than before. Consider the difference in the two collisions. Explain in a paragraph why passing through the block produced a different velocity for the block than when a bullet gets stuck in the block. In your description, be sure to incorporate ideas about inertia, momentum, and impulse. So, although those three words are there, how you describe them in your paragraph really will depend upon the way in which you decide to describe this. This problem is about the change in momentum of the bullet. The bullet experiences a larger change in momentum when it is stuck in the block than when it passes through the block. This is due to the fact that it has a larger change in its velocity. Due to Newton's third law, that must mean the block experiences a larger change in momentum as well. So I would focus on the idea that the impulse is larger when you slow the bullet down more. And because of Newton's third law, that means the block has to experience a larger impulse. And even though the block has more inertia than the bullet, it experiencing a larger impulse is going to cause it to have a larger velocity when the bullet gets stuck. You could extrapolate this to a problem where the bullet bounces off the block, where the bullet experiences an even larger impulse because its momentum was changed even more greatly. I would expect the block to have an even larger velocity after that collision as well. I don't think you have to say very much here. I do believe you have to explain how the impulse of the bullet is different and the fact that the block has to have an equal and opposite impulse, and that a larger impulse on the block is going to result in a larger change in velocity for the block. I think if you cover those three ideas, you would probably get all credit. I would probably think this would be a 3-point question with those three ideas trying to be brought up. So clearly, impulse of bullet has to be discussed. Then Newton's third. This attaches the impulse of the bullet to the impulse of the block, and then the effect of the impulse on the block. That would be what I would expect. Any questions about this page? All right. I don't believe this is particularly tough. So I mean, if this were on a test tomorrow, and it's not like it's a surprise. I know it's on a test tomorrow. I think this is of the appropriate level. I don't think it's a particularly challenging question. So next page. Now, I don't know that this year I'm going to have a full FRQ question on the test that's got a graph like this. But I don't think you can escape a momentum graph. You know, this is an impulse graph, really. I don't think you can escape it. We had a lab on it, and we had several questions in your homework based on it. So I think you're going to have to be able to use this graph of some form or some shape. And I think that it's not crazy to expect that you understand that the area under this curve is the impulse. So this graph represents the force that occurs on an object during a collision. The collision lasts 0.01 seconds, and the collision occurred in a 0.5 kilogram dynamics cart initially at rest on the track. What is the impulse experienced by the cart? What's the likelihood I'm going to leave a hint like this on your test? Very low. So, yeah, I'm expecting you to know that tomorrow. So bring that with you, okay? This one's pretty easy, though. I mean, it's just a triangle, so 1/2 base times height. And so something like that. So was that 2.5 kilogram meters per second? Oh, probably put the number there. What is the change in momentum of the cart? I don't think I'm going to be doing redundant questions like this on the test. I think I put these on the practice test to ensure that you could be stepped through the thought process, that either one of these questions could be asked. They mean the same thing and would come from the same place. So I don't want you to be lulled into believing I'm going to do that on the test tomorrow. You guys tend to think that the practice test is the test. It's not. So I could ask this question without asking question number one, and my expectation is that you understand that the area under the curve is the impulse, and impulse is force times time or change in momentum. Yes, ma'am.
Isn't the mass supposed to be 0.5 kilograms instead of 500 grams?
Maybe. I haven't used the mass yet.
No, for the first one.
I still haven't used the mass yet.
Wait.
All I do is find the area under the curve.
Okay, that makes sense.
You sure?
Yeah.
In case somebody else didn't see that and doesn't want to out themselves, I got the force here, right off the graph. So the height of the graph is the 500 newtons for the force. What is the cart's velocity after the collision? I think that's a reasonable expectation to ask either the cart's velocity after the collision or the cart's velocity before the collision. Remember, this is change in momentum. So if you know how fast it's going after they collide, could just as easily ask you to use the impulse to figure out how fast it was going before they collide. So don't get too confused by this. This is final minus initial. It just so happens in this question, they tell us that the cart was at rest before it was, hit. But, we did in our lab, we didn't do it that way. In our lab, we measured the velocity before and after it was hit. So you could use this impulse in the opposite way to find out what happened before. I'm not giving you a hint. I'm telling you that's probably more likely on the test tomorrow. See if you can adapt to a different kinds of question. But this one is going to be our 2.5 kilograms meters per second equals 500 times V final. Oh, wait, the mass of the cart's not 500. The mass of the cart's 0.5. 0.5 times V final. Is that just 5 meters per second? If the cart that caused the collision was 1 kilogram and was traveling at 2 meters per second, what impulse did it experience? Newton's third law, the cart that caused the collision must experience an equal and opposite impulse. And what was its final velocity? Well, I can still do the work here. That's going to be P final minus P initial equals negative 2.5. I'm going to assume the cart was traveling in the positive direction at first. So this is going to be 1 times V final minus 1 times 2. That still equals negative 2.5. I'm going to add the 2 to both sides. And I find that V final equals negative 0.5 meters per second. So apparently this cart bounced off of the other cart and is now traveling in the opposite direction. Yep.
So I'm looking at it and I see that like 1 times 2 is good. So 1 times 2, where did the 2 come from?
The mass of the cart. In all of these cases, momentum is mv. It tells us it's a 1 kilogram cart, right?
Right, okay.
How's that, everybody? So apparently your test is going to take 15 minutes. It will be longer.